I'm Dennis Heldman. I'm a professor at The Ohio State University. My teaching and research program deals primarily with food engineering, but these days I've decided to place a considerable emphasis on the topic of sustainability. I guess I should point out I was also an IFT president a number of years ago, and I'm very pleased this morning to visit with a close colleague, John Litchfield. John, could you talk a little bit about your background?
Yes, I'm John Litchfield. I'm an adjunct professor in the Department of Food Science and Technology at Ohio State, and my main responsibilities are in the area of product development at the present time. But I've had many years of experience in this water waste management field, and this has certainly come to the fore. I've been a past president of the Institute of Food Technologists, and so that literally sets the stage for what we're going to say this morning.
There have been a number of sessions at this annual meeting. Even our opening session speaker topic was sustainability, and then there have been other sessions. John, talk a little bit about how we as scientists interpret sustainability.
This is a really big question because people have definitions of sustainability that vary from one another. I like to use the definition of that as optimum use of resources to achieve the desired end. For example, we have water resources. How do we achieve optimum use of these to fulfill the requirements of the food industry and yet prepare products that the consumer likes to buy and eat? So it's a broad, definite subject, and one that people have different views on, but at least I think this is one working definition because it extends all the way from the point of production in agriculture right through to the consumer at home. And this is a very broad range of activities, but they all contribute to this sustainability question.
Some of these statistics that we keep being reminded about indicate that one of our challenges as members of the food industry in a broad sense is that our population will increase to 9 billion by the year 2050. And the challenge is going to be how to deliver the amount of food that's going to be needed for that population. We also know that we're going to have to do that in a period of history where the resources to do that are even more limited than they have been in the past. So what is the focus of research and other technologies that are going to be needed in order to allow us to achieve that?
Let's go back in time to a little historical background. First, water resources on this planet, only about 2% of fresh water. The bulk of the water on this planet is saline water of one kind or another, ocean or inland lakes. This puts a constraint on what we can do feeding the population because we only have finite water resources. Secondly, we have to consider how this water will be distributed. Who will have access to it? How much will they pay? And this is a critical issue for the food industry, is how do we conduct our operations with this limited resources of which we're going to have to pay an increasingly higher cost. Now the technologies that can be evolved here, we have available to us now. Many of them have to be improved, but we have, for example, purification of waste streams by biological and biochemical processes. We can purify the effluents by membrane technologies such as microfiltration, even nanofiltration, processes like osmosis. So there are a lot of processes out there, but we have to improve many of them to meet the requirements that we're going to face in the future. And I think that's where the challenge in research is. How do we improve the membranes that are more durable, less fouling problems? How do we disinfect the water that is related coming from these operations? So we have a lot of research and development challenges here that yet to be met.
Okay, it does seem as though the technology for converting seawater to freshwater has been around for a long time. What is the limitation on that, using that technology?
We have the technology at a price. For example, Saudi Arabia and those regions have long had desalination technologies in place, but they pay a good price for that water. Increasingly in the United States, coastal cities will be required to desalinate. We see such operations at Tampa, Florida right now. I believe San Diego has one. We'll see that to an increasing extent. And this is going to raise the cost because water was always looked at by even the industry as something that was cheap and easily available, and so we didn't have to worry about it.
So we haven't been traditionally very careful about how we use the water that's available to us. That seems quite evident. So we need to not only look at desalination as an example of something that's out there, but also look more carefully at conservation, reuse, recycle, reclaim the water that we use in our operations.
Yes, and I think this is very interesting. There have been several studies in the beverage industry. We'll consider the beverage industry broadly. The brewing industry, the best brewing industry practices use about 3.5 barrels of water per barrel of beer. We have a large number of craft brewers in the United States, very rapidly growing, nowhere near that effectiveness in water reuse or even consumption. There's a whole host of industries like this. Carbonated beverages, same thing. They have a problem, and they think, at least the current thinking is that this is one of the biggest crises that's going to face the beverage industry in the future is going to be the cost of availability of water. If they're water-based, then they'll use a lot, and the cost will be higher.
Let's shift gears a little bit to a topic that I feel rather passionate about, and that's waste. You see more and more reports about the quantities of food that are literally wasted. In my mind, there's a cumulative effect. We have used energy to create those products. We have used water to deliver those products. And ultimately, quite often, even in the home, they're thrown away. So this seems to be an area where conservation can really begin if we just find a way to reduce the amount of waste. We'll not only save the food, we'll save the water, we'll save the energy that was used to deliver those products.
It's very interesting. The U.S. Department of Agriculture Economic Research Group statistics on the 20 best figures that are available, the 2010 figures show that about 30%, 31 odd percent of all the food out there is wasted, especially in this chain from restaurant, from retail, restaurant to home. That seems to be the focus of the problem. It looks to me like we have to look at consumer education and distributor education, a whole lot of actions like this that are going to be needed to change people's attitudes toward this. But I'd like to even look farther back in the food system. For example, of the amount of product that is harvested in the field, how much is lost between there and the consumer. And you see, that's another issue that needs to be looked at, is every point in the food chain, from producer through to consumer. We have a vast system, and I think it's going to require a systems analysis type approach to determine what are the best practices that could be used at every single point. And I think that's probably a challenge for the future. I'd like to mention the National Aeronautics and Space Administration life support programs that came into effect during the moon expedition many years back, and also in the current International Space Station. The big advantage in that whole effort was applying a systems approach to the water, waste, food management cycle, so that they had a thorough understanding of every factor that was affecting this cycle. And I think we're going to have to adapt that type of approach to our total food system from producer through to consumer. I think that's kind of a model that we need to look at.
Certainly, if we look at this challenge globally, and we have to, since those 9 billion people by 2050 are distributed globally, there are contrasts that we're aware of between developing countries and developed countries. So what you've mentioned in terms of looking at the system from the point of production all the way through to delivery to the consumer is going to be critical. Let's look forward. What is it that you would anticipate might be some of the breakthroughs?
Well, I think certainly we mentioned one breakthrough, and that's educating the consumer and the retail chain part of this whole system to do a more effective job. I think that is beyond technology. It may be some technology there, but I think it goes over into the social sciences of how do you educate people to do things differently. The other thing that I think that is very important is to look at how cost of water management can be reduced. I mean, we're talking about desalination technologies. So can we get improved membranes and disinfection systems that cut the cost in considerable level? Another thing to consider too is a recent news item mentioned that H.J. Heinz and Ford had teamed up to make a bioplastic out of skins and tomato skins and seed, and use that in some of the appurtenances in the Ford manufacturing of automobiles. And it certainly is a kind of a novel approach, but it apparently can be done. And I think more of that kind of thing has to be done. How do we use the solid waste that we have in the food industry to make products that are useful to industry at large? And that, I think, is a challenge also for the future, because we have a lot of solid waste from the food manufacturing sector.
We haven't really talked much about packaging. A lot of what we read indicates that when it comes to the landfill, that the various kinds of packaging, quite often that's associated with delivering foods, is in packaging that sometimes seems excessive. What do you think might be happening in that arena?
Well, I think packaging is so consumer market driven that oftentimes I think that dominates, and maybe the overuse of packaging beyond protecting the product is sometimes could be a problem. We have now some biodegradable packaging materials that are coming into increasing use. And as they're rather expensive now, but I believe that with the production increasing, they will be more likely to be used as their quality improves. For example, polylactide polymers are very biodegradable, but they have a brittleness factor, and so they'll have to be formulated with more increasingly with other polymeric materials that are biodegradable in order to make this truly a sustainable type of packaging. So I believe that's a challenge for the future, is how to develop these technologies that will give us the packaging materials that can display the product, protect the product, and yet be environmentally effective.
I guess we could even get a little more exotic. Occasionally, I read and hear about even edible packaging. Is that a possibility?
There's been a lot of work done on that, and University of California, Davis, and U.S. Department of Agriculture, Western Research Center, and certainly that is approached, but there's a lot to be done there. I mean, I think, and I think maybe that again, public education, people probably a little bit questionable about whether I should eat this package. So I think that's probably going to be another factor here in acceptability of these types of products.
Well, I think, John, this has been very, very interesting and helpful. I hope that we've touched on a number of topics related to the whole area of sustainability, at least from the standpoint of energy, water, and waste. So thank you very much for this opportunity.
Thank you.